So I'm going to look at, okay, so we'll do this example. So we'll so we, okay, so what we're going to do is let's go ahead and read the what example I'm using? Universal bank example, okay? So I'm going to copy paste that here, and then say bank, and that will be Universal Bank. Okay, and say Universal Bank, we don't want we don't want a couple of variables here. ID, we don't want ID, and we don't want zip code. Okay, so if you want to use the name and not the column number, you have to use subset. Subset bank.df, and then you say select equal to -c, and give a vector of the names you want. Names you want to include, then you will not put a minus sign. Now we want names to be excluded, so you put a minus sign, and now when you use subset, okay, you don't put the variable names in quotation marks. Okay, you shouldn't do that. So zip code. Okay, so now we have bank.df has 14 variables right now. When you run this, hopefully it will be 12. Okay, so these two variables are now gone. Okay, now let's split. Okay, set that seed 1, then we'll create partition. So we say train dot rows equal to create partition, and we want bank.df personal loan is our target. Okay, and say p equal to 60%, 0.6, and then we have to say list equal to false. Okay, and then we can do train .df is bank.df. Okay, train rows and all the columns, and then valid.df equal to bank.df minus train.rows, comma everything. Okay, so now what did I do? Train rows. Okay. All right. So now we have the partitions. Okay. All right. So now we're going to use the rpart.control to control the tree. Okay. What kind of parameters we want to use in when we train the tree. Okay. So here are some of the options that we have. Okay. We can use okay. So rpart control, okay, min split, okay, default is 20. So that's the minimum number of cases in a node for a split to be attempted. So if you want a full tree, then you put a very low number. You say min split is 1, then you're going to keep on splitting, okay, until you get the whole tree, the full tree. Okay, so the default here is 20. Min bucket is the minimum number of cases in a leaf node, the final node. Okay, and then we have CP. I don't know why CP is on the side here. It should be, okay, CP is the complexity parameter, and your textbook discusses this. Complexity parameter is when you keep splitting, right? So it's a way of controlling overfitting. Okay, when you split, your error will always go down because you're going to keep, as you split more and more, you're clarifying more and more. Okay, so there will always be improvement, but the problem is the improvement is so negligible that it is not worth it to split. So you take the misclassification rate or error rate, and then you add a penalty for the number of nodes. Okay, so there'll be alpha times the number of nodes. So as you increase the number of nodes, alpha times that is added to the error. So the error goes down, but the number of nodes is going up, so it adds a penalty and it takes this whole thing up a little. Now, if the reduction in error is significant, then the penalty added will not come, undo the whole thing. It'll probably, take away a little bit of that reduction, but not a whole lot. So that's good. But if the reduction is very small, and so by adding the penalty, the total really goes up then. Okay, so then you stop. That's what CP is. So we'll be using CP for pruning purposes. Okay, and then so for ANOVA, splitting is done by R squared, and it must increase by CP at each step. Okay, so minimum information gain. So that's what that is. Okay. Now max compete is, it looks at substitute splits, so we're not going to get into that. Now xval, okay, so this is important because our part has cross-validation built in. So you don't have to use the caret cross-validation. So you can specify cross-validation by using this xval. Xval equal to 3, then it's going to give you 3 folds in cross-validation. Xval equal to 10 is going to give you 10-fold cross-validation. And then maximum depth is, of course, from the root node. Root node is depth 0. Okay, and then how far down you want to go, maximum depth. So you can specify that as well. Okay, so let's look at an example now. Okay, so here is the CP computation. Okay, let's do a default tree. Okay, so we have done all this already. Okay, so train and plot default tree. Okay, so that will be bank.tree that default equal to R part, okay, personal loan and all the variables. Personal loan is the target, and data equal to train.df, method equal to class. So personal loan is 0, 1. Since it is numeric, it's not factor, then it's going to assume class will be ANOVA. So we don't want that. And then we do PRP bank.tree.default. So then here is the tree that you get. Now you can specify some parameters for tree, for plotting. So here are the different types of tree that you can plot. So 0 is the default, so you get only the split label. And if you use 1, then you get label for all nodes, 2, and so on and on. Okay, so then you have the extra display options, and then we have the box palette for color coding. Okay. So here is, let's do the same plot. Okay, bank.tree.default. Let's use some of the options and then see what happens. Okay, and then we have extra equal to say 2, and then box palette equal to auto. Okay, so we're plotting the same tree that we trained here. Okay, and when you don't use any options, and you let all the defaults play out, this is what you get, which is not really very good. So when you use this, see what happens, and you get a much nicer plot of the tree. So you get the labels of what the split is about, okay, and then you get color code, so which is the zeros and ones. Okay, so blues are zeros, okay, greens are ones. Now the darker shade means there is more of it, okay, more pure of whatever that majority class is. So all the blues are majority 0, and darker the shade, more pure it is. Okay. Now green shades are ones, majority ones, and darker is more pure. Okay. And you can change the type. Okay, suppose if I say type equal to 2, then you get some, you change the way things get printed. Okay, to use type equal to 3, then you get something different, and so on. Okay, all right. And same here for extra. You can, so if you add 100 to it, you get some percentages printed too. So what percentage of observations are in each node? So the root node has everything, 100%. This node has 81% of the observations, so this one has 19%, and so on. Okay. So how the decision tree gets printed can be controlled by these parameters. Okay. And you can set the palette to something that you want. Okay. Instead of auto, you can control the palette. Okay. So suppose if you say bank, okay, you set up bank pal, okay, and you need to give the colors as a vector. So green for green 2, okay, and then blue for blue 2, like that. Then and then you use, instead of auto, okay, so you use the palette that you have set up. Okay, so that's the problem here. Okay, so is it okay? All right. So now you see your palette gets used instead of auto. Okay. All right. Okay, so we still haven't gotten into how to control, how to prune, and all that. So these are some basic general, way of developing decision tree. Okay, default, using defaults, and then controlling how we print the decision tree. So we haven't gotten to developing trees that are off of default, okay, which we will do next time.